Hello, and welcome to Software Architecture Monday. My name is Mark Richards, and in this lesson, number 198, we'll take a look at an anti-pattern of event-driven architecture called the Swarm of Gnats event anti-pattern. You can get a listing of all the lessons I do in Software Architecture Monday through my website at developer2architect.com/lessons. Back in lesson 165, I talked about event-driven architecture as an architectural style, how it works, what it's good at, and what it's not so good at. If you're not familiar with event-driven architecture, I would recommend stopping this video and watching lesson 165 first and then returning back to this one. I think it might make a little more sense. Now, the Swarm of Gnats event anti-pattern is an anti-pattern of event-driven architecture. Now, gnats are these small, flying, annoying insects that swarm in front of your face while you're outside. And as a matter of fact, so annoying, it makes you want to go back indoors. Well, like the swarm of gnats, this anti-pattern is about creating too many fine-grained derived events, just like these gnats right here. And like those events, what we want to do is simply just swipe all those away. This anti-pattern really has to do with the number of derived events you should trigger from an event processor or a service. These two terms are interchangeable, so I'm going to use the word service in the context of this video. So let's take a look at an example of charging a credit card. So an initiating event comes in, credit card has been charged, and two other services respond to that. A fraud detection service to detect whether there's any fraud or not, and also a credit limit check service. Well, let's focus on the fraud kind of detection service. Notice that in this example, the fraud detection service, when it checks to see if that charge might be fraudulent, sends out two different derived events. One that says that fraud's detected, and a separate event that says no fraud detected. Now, it turns out that we have a couple of services interested if fraud was detected. First of all, there's a credit card locking service that if fraud was detected, this will lock your credit card from any further charges. And also a customer notification service that notifies you through email or text that it looks like you might have a fraudulent charge to take a look at. Now, if no fraud was detected, a separate derived event is sent, and we have kind of a charge profile service. This is your billing or buying profile, and that's interested if no fraud's detected because we can add that kind of charge history to your profile to better detect whether something is fraud and to kind of get a better understanding of your buying patterns. Well, the nice thing about this model right here is now that we're sending two different events, the credit card locking service and customer notify respond and take action if fraud was detected. But if no fraud was detected, they don't respond to that event. But the charge profile does, and that one takes action. Okay, let's make one change to this structure right here. And instead of two events, the fraud detection service is only going to send out a single derived event called fraud checked. So I checked the fraud, and in the payload tells the information about that verification check, whether it was deemed fraudulent or whether it wasn't. Now, the problem with only sending one event is the fact that the credit card locking service must respond to that single event and analyze the payload and decide whether to take action or not. In this case, there was no fraud, so the credit card service unnecessarily is doing all this parsing of the payload, analyzing and saying, nope, I don't need to take action. The customer notify service also must respond to this event because it might have been fraud. In this case, it wasn't, but it has to interrogate that payload of the event and says, nope, no action. But the charge profile service does take action because no fraud was detected. So you notice the difference here. When I sent out two events, in other words, more events, it made a lot more sense because services could choose what to respond to or not. But when I only sent one event, now all of a sudden every service has to respond and decide whether to take action or not. What does this have to do with the Swarm of Gnats event anti-pattern? Let me show you through a separate example, and then we'll come back to this one. So let's say we've got a customer profile service. Now, the customer wants to update their bill to, ship to, and cell phone number because they moved, let's say. So they go onto the website screen, fill out all this information, and hit enter. That single request comes into customer profile. So it says, oh, we need to update the bill to address. So it does an update in the database and then triggers a bill to address updated event. It then goes and says, okay, now let me update the ship to address, and now triggers another event, the ship to address updated. And finally, it updates the cell number and triggers a separate derived event. This is a great example of the Swarm of Gnats event anti-pattern, just like those annoying ants flying in front of your face that you're trying to swat away. So several problems happen with this. Assuming that after each state change, a derived event is triggered, this action might end up being rolled back because there's really 3 actions taking place here. So I have triggered events where, in fact, I'm really not done with this single operation. So that's problem 1. Problem 2 is that these small, detailed events tend to saturate and overwhelm the system, and it becomes really difficult to analyze and track and understand the overall workflows within event-driven architecture. So one way of avoiding the Swarm of Gnats anti-pattern is to consolidate these derived events. And let me show you the same example. Customer wants to update the bill to address, ship to address, and cell phone number. They update those on the website, hit submit. The single request comes into customer profile. It updates all 3 of these pieces of information, does a commit in the database, and then sends out a single derived event, profile updated. And in the payload contains the before and after data for each of those things that were updated. For example, the bill to address, ship to address, and cell number. But it's not quite that simple, because it's not about always consolidating the events. You see, if we go back to our credit card example, do you remember when we consolidated all those events into one single event? That didn't work so well. And because it required a lot of churn and unnecessary processing and unnecessary responding to that event from certain services. Whereas if we split it into 2, notice it's much more effective, much more efficient, and we can actually trace the flows of what happens when fraud was detected. You see here, if fraud was detected, all 3 of these services are responding to that event and interrogating the payload, which means I don't have a clear understanding of the event flows when fraud actually is detected because all the services are responding. Here I do. But if we have too many of these, I just gave you the advice to consolidate them. So which one is it, Mark? Do I consolidate them or do I have split ones? Well, one way of being able to determine whether you're in the Swarm of Gnats event pattern and also to overcome this anti-pattern is really focus on the outcome of that state change, the outcome of the processing of a service. You see here, the outcome of that customer profile service was to update the profile, that the profile was updated, regardless of what information was. And that's a lot different than the fraud. Let's go back to the fraud detection, where in fact this is outcome based. Either fraud is detected or it's not. So one word of advice about avoiding the Swarm of Gnats event anti-pattern, and that is this: focus on the outcome of the events, not the individual things that are happening, but what the outcomes are. And that helps avoid the Swarm of Gnats event anti-pattern. And also, if a service has to interrogate the payload, in order to determine whether they should respond and take action, that's also a good indicator that we probably want more events than fewer. And so this has been lesson 198, the Swarm of Gnats event anti-pattern, all about guidance in terms of the granularity of those derived events from a service. And so thank you so much for listening. Stay tuned in 2 more Mondays for lesson 199 of Software Architecture Monday.